This is Dr. Rody, and in this video I'm going to talk about the features here of a frequency table, and then I'm going to do a example of calculating relative and cumulative frequencies using this table that you see here. So with the frequency table, it takes the data and it summarizes the counts of data as it falls through certain classes. The classes are these rows that you see here in the table. Now in this case, the variable here in this first column, time, happens to be also a quantitative variable. Sometimes you can have a qualitative variable here, like let's say you're counting sales of the color of a car that's sold on a car lot. Let's say you own a car dealership and you're trying to track which colors maybe are more profitable or desirable to the customer. And you might have colors here and then you count how many sold. In this case though, they took time, which is a quantitative variable, and they counted up how many times that the time in the drive-through was 75 to 124 seconds. It was 11 times, and all these other ranges as well. Now one thing to notice is that all these widths are the same. Once in a while you'll get to the end and it might say 275 or greater, but usually these widths are the same. And these numbers here, 75, 125, 175, that's called the lower class limit. So that's lower class limit. So you might have some homework questions that ask for lower class limit. That's those numbers. And I think you can probably surmise that the upper class limit then will be the numbers on the right there. So the upper class limits are simply the numbers there, 124, 175, 224, and so on. Now you also might be asked for the class width. The class width is the difference between two class limits. So the class width in this case, you might want to say 124 minus 75, but that's not what you do. You're going to take 125 minus 75. It's the limit, it's the difference, between two consecutive class limits, so lower class limits, let's say. And in this case, that's 50. So the class width here is 50. In a frequency table, you might also be asked to find the class midpoint. So for the class midpoint, just average the lower and upper class limits. So if I do it for this first class, if you add 75 and 124 together and then divide by 2, you get 99.5. Now we established that the class width is 50. So to do the next midpoint, you just add 50 to each one of these. And when you do that, you will get the class midpoint for each row. So these are the class midpoints. And those are useful if you are needing to make a histogram from this data. Then you can use these class midpoints as the center of the bars of the graph. So now let's figure out the relative and cumulative frequencies. The relative frequencies are simply the proportion of data that's in that row. And usually we write this as a percentage. So I'm going to put a little percent sign here, but you don't always, sometimes that you can enter it as a proportion. When you're doing your homework, just look at the instructions. It will tell you whether you should make it a percentage or not. I put the percent sign here, so the numbers I'm going to put down will be the percents. You'll see with the math on the computer. So first thing I want to do is add up all these and figure out how many total I have. So if you add up all these, you're going to get a total of 50. Now I simply look at how much is this frequency in this row relative to the total? So that's a straight division here. So I get 0.22, and as a percent, and let's say it wants you to round, a lot of times it'll ask you to round, so let's say to the 10th of a percent. So I'm going to say 22.0%. Right, I already have percent there, so I'll leave that off because I've indicated percent right there. So now 24 divided by 50. So 48%. And I'm doing the 0.0 because I said, oh, round to the 10th of a percent. It could say whole percent, it could say 100th of a percent. You have to pay attention to the instructions when you're doing a homework problem or a test problem. In this case, 20%. 50 is a nice number, so we're not getting, we're getting nice whole percents here. 3 divided by 50, 0.06, so that's 6%. But if I'm rounding to the first decimal, I need to put the 0.0 there. And then 2 divided by 50, and you can probably do some of this in their head. And what we get is 4%, right? So I'm just moving the decimal to the right two places in my mind. If it doesn't ask for percent and it wants proportion, then you put these proportions, you know, as they are here in the calculator. So just be aware of that. Then for cumulative frequency, so I found in the past that students get this correct more often than the cumulative actually. The cumulative seems to have more errors. All that means is accumulate from that row backwards. So the first row, there is no backwards. So in other words, how many are in this class, this first row or class, or before? Oh, that's 11. Well, how many are in the second class or before? Cumulative, you're accumulating as you go down. If I'm accumulating, I do 24 plus 11, right? Which is 35. All right. And you can also go look at it like this, 24 plus 11. So now I need to go to the next one. I have 35 already. There's 10 more, 45. So the key is understanding the definition of this, because the arithmetic is really easy, right? So it's just knowing your definition. So that's where reading the textbook is really important in the statistics, as opposed to like some algebra classes where you can practice the algebra a lot and you maybe don't have to read it a lot. But in statistics, the language is so important and the definitions are very important. So let me continue. 45 plus 3, that's 48. I'm simply accumulating the cumulative frequency. Cumulative frequency. I'm just accumulating as I go down. And when I get to the end, this last total should match the grand total that we computed before. And that's how you do relative and cumulative frequency.